Okay, we're gonna do some stay awake exercises in class now. I'm gonna come up with this number for the ideal gas molar volume, both in SI units with cubic meters and kilogram mole, and for field units with standard cubic feet and pound mole. I'll have to provide you the various quantities, since you probably don't have it in front of you to do that. So I'll just put SI and field here. So we need the pressure in standard conditions, temperature, standard conditions, and the constant, which you should actually already have. This is 1.0135 bar. This is 14.696 bar. Absolute. PSI absolute. This is 15.56 degrees C. I'll have to convert that to Kelvin. This is 60 degrees Fahrenheit, and you'll have to convert that to degrees Rankine. You'll do that by adding 273.15 and adding 459. .67. That's the conversion you need. And then you've got the gas constant. That was 8314.4, I think. And maybe it's safest to go to the appendix here to pick these numbers up. Okay, we've got 10.315, 10.7315, 8, that is 314.3 here. Let's see here. I think that's everything you need. We're going to come up with okay. So that's the first problem. I'll come back to that. I just want to give you the second problem if you finish this very quickly, so you can move on to that second problem. And that is, we're going to talk about the Troll. This is a Norwegian, this is the largest, I think, European gas field, the Troll field, and it's only the gas part of it because it also has a very large, about a 5 billion barrel underlying thin oil zone. But we're only talking about the Troll gas volume or reservoir. And here, the initial gas in place, we don't usually write it that way. We usually write it as initial gas in place. This gas being surface gas, surface condition gas. Sometimes this is written original gas in place. Maybe there's some other terms. The symbol for this in the SPE is capital G. That's the SPE symbol for this quantity. These are just short names: initial gas in place, oil gas in place, original gas in place. And this number is about 45, what we call TCF, which is the same as 45 times 10 to the 12th standard cubic feet. And I want you to do a 4-step procedure. You're going to first calculate the number of moles in the reservoir in pound moles. Then I want you to convert that to kilogram moles. Then I want you to go to this, what I'm calling basically this G, in standard cubic meters. This would be B, C, and then D. I want you to check this C using the units conversion 35.31 standard cubic feet per standard cubic meter. That's a number that we've okay. So that's these are the two things we're going to try to do today. And then I'm hoping that we'll also have a little bit of time to do some Excel, simple Excel with the ideal gas law using some plotting. Okay. Okay, so this problem 1 is that we want to have VG. Well, that is just pressure. I'm sorry, that's already wrong. That's R TSC over PSC. Okay. So what do we get here for Kelvin? And now I'm going to expect somebody out there to give me these numbers. I suppose I can do it myself, but
Kelvin is
288.71 Kelvin. And then I'd like someone to give me a yo. That means that you agree. Or no, if you don't agree. All right? Because I got to have, I screw up, you screw up, but if you get 2 or 3 numbers, yo, yo, you know, then we feel comfortable, right? Okay. So we got any yo's on this guy? All right. There we go. I heard two very weak ones.
Yo.
There we go. I don't give better grades for low yo's. So, all right. So what about this Rankin?
511.767.
Okay. All right. So we've got the R, we've got the TC, and we've got the PC. The R, the TC, or the TSC, and the PSC. So what do we get for this standard gas volume here? Molar standard gas volume. 684. Okay. I never remember if it's 8 or 7 or what, but okay, so 23.68 I think is probably good enough. And then for the field units,
379.48.
right. I'm going to give ourselves 5 digits because I think we haven't brought in more than 5 digits here. So I'll just make this 8 and 45. No, what was the number? 48. It's 379.48. So we'll just give it 5. Okay. I want to hear those U's. Y'all aren't going to go for that. Now, if I was a rapper, you know, Jay-Z or some kind of cool guy, y'all would be yoing all the time. You know, it would be like no brainer. A boring old man from Oklahoma. So, all right. So those are the numbers. Any questions? You need to make a decent grade on this exam. And that's not the purpose of why we're here. But I know everybody would like to have a decent grade on the exam. You need to know how to use this guy, calculator. It's number crunching is all we do on the exam. You number crunch. So if you don't do it in class and you do everything on Excel in the home exercises, when you get to the exam, they don't let you have Excel. You're at a big disadvantage. I just tell you, even you understand all the material, you're going to have to punch numbers and you're going to have to do the calculations. So just get used to it. I understand it's old-fashioned, but it is the university and not me that says you can't use a computer on the exam, that you have to use this little unfamiliar calculator. Okay? But the exams are computational, so get used to it, and so that's why we're doing these things in class. So now we want to convert from this volume here, standard volume, to moles. So how do we do that? What's our conversion factor?
Divided by
379 standard cubic feet per pound mole. Okay. So what do y'all get? 11.87. Times 10 to the 10. All right, let's put it this way. At least say no if you get something different. Okay, and don't be worried about, oh, I might be wrong. He's probably right. You know? Huh? Yo. All right, there we go. So we got 11, well, you know, 10 to the, we got 118.7 billion pound moles. And to get kilogram moles, we're going to do it this way. We've got a conversion factor that we already know, which is 2.204 pounds per kilogram, right? That's a number we've already talked about. So I'm going to say 2.204 pounds, and if we write pound or pound mole, it doesn't matter, per kilogram or kilogram mole. And that will give us, because these cancel, 5 something. 5.3? 5.39? 10 to the 10 kilogram moles. Okay? And then we can take that number and convert to standard cubic meters. By using this other number, 23.68, which converts from standard cubic meters, or from kilogram moles to standard cubic meter. Cancel, cancel. Hundred and something.
127. 7.57.
Those are the kind of numbers you'll read in Dagens Næringsliv in Norway. They'll give it in standard cubic meters. Of course, they don't have the 10 to the 10th in these financial newspapers, so they'll probably write milliard, billion, in which case it would be, or maybe, well, what's beyond milliard in Norwegian? Million, milliard, billiard? In Norwegian. You guys won't get this one. What's the Norwegian for 10 to the 12th? Don't know? Well, they'll have to say 1,276 milliard cubic meter gas. Billion? Which is messy because billion is in English is 10 to the 9th, but I think you're right. It is billiard. I think in Norwegian sometimes you'll hear people saying billiard, meaning 10 to the 12th. But it's kind of a dangerous thing to do. So probably the financial paper will write 1,275 milliard 10 to the 9th. Yes. Okay. And the Norwegian newspapers will also, in the section per standard cubic meter, they'll give a price for this. Okay. So we want to check this value of C by using the 35.31 directly from here. So if we take our 45 10 to the 12th standard cubic feet times 35, 31 standard cubic feet per, we should get the same number, right? What do we get? Huh? All 4 digits? How many digits? Just read me the number. 1, 2, 0.4. Okay? 10 to the 10th. Now, this is round off because of digits and enough accuracy and so forth. But what I want to do is I want to emphasize a little bit. Well, who cares? It's a 4th digit, right? I just want to put this a little bit in perspective. Okay. So, if I'm telling you that we have in Norway, it's about $5. It's much better than the United States, which is half of that, per 1,000 standard cubic feet. That's a price. I don't know what Norwegian crowns per standard cubic meter is. I don't know that. But I do know that there are about 6, it's a little less than that now, Norwegian crowns per US dollar. All right? So I can take times 6 NOK per US dollar. And then I've got this 1,000 standard cubic feet. I got to get rid of that. So I write MSCF, 1,000 standard cubic feet, right? Now I want to get rid of that. So I've gotten rid of this. I've gotten rid of that. Now I want to get rid of the standard cubic feet. So we do this. Right? Units conversion is basically just getting rid of things consistently. Because when I do this, that's the same as multiplying by what? By 1. That's the same as multiplying by 1. That's the same as multiplying by 1. So we end up with NOK per standard cubic meter of what? What's that number? At least the Norwegians should be very enthusiastic now, because we're finally getting to money, which is why you're here, right? You all chose this linje because you had the highest engineering prices in Norway, are you guys, okay? When you leave here in a couple of years, you'll be making more than I make. Shows my level of intelligence being here instead of out in the industry like you will be. But hopefully one of you Norwegian ladies will stay behind and become a professor, the first petroleum engineering professor in Norway. I'm hoping. Okay. Not so intelligent like me, you know, low salary, but you know, still, it's a fun thing to do. Somebody's got to do it, right? Like carrying out the trash. So what number do we have here for Norwegian crowns per standard cubic meter? 1? 1.05? That's a nice number. At least you can remember it. Okay, a Norwegian crown per standard cubic meter. Now, I want to put in perspective, a little bit of perspective, the difference between 127.6 and 127.4. Okay, 0.2 10 to the 10th standard cubic meters times 1, because it's not $5 per MCF, it's about that, NOK per standard cubic meter. Is that right? 2 billion NOK. Yes? Did I make a mistake? Multiply it by. Okay, I didn't. Yeah, it need to be 6 times 1. Yeah, that's right. Should be 6. Let's see, when we did this 1.05, you took 5 times 6 is 30, divided by 1,000 times 35. Is that what you did? It's 5 times 6 is 30, divided by 1,000 times 35. Well, 30 times 35 is about 1,000. So I think it is right. Okay? Now, I like to introduce a unit early into the course so that people appreciate these big numbers, you know? 2 billion crowns. You obviously know it's a lot of money. Because 2 billion crowns is, well, it's $500 million, and I mean, that's a lot of money, okay? So I like to introduce a life salary unit. Okay? It's what you're going to be making in your entire life. Okay? Now, for an engineer, I'm just going to say that all the discounting and future and so forth, that if on average your salary is 700,000 crowns, that's more than $100,000 per year, times 30 years. Okay, so what's that? Huh? 21 million NOK. You didn't realize you're a millionaire. Okay? 21 million. Which is how much of this? What percentage of this error? We're just talking about the little bit of error coming from the round off. 2 billion crowns. So how many of us do we need to make the 2 billion? 100 of us engineers, right? So this is approximately 100 life salaries. It's about as many in this class. Our entire life salary, of course some of you are going to end up being real rich. We're going to ignore you. Okay? About our entire life salary in this group here is just what we got is a round off error in doing these calculations. Okay? Unless somebody says, no, Curtis, you screwed up again with your conversions. Okay. Okay? So, be careful with your numbers. Don't be sloppy. Because don't be any more sloppy than you would be if the bank starts rounding down, you know, the money they put in your bank, in the company, and they just round it to the nearest 1,000 crowns or 10,000 crowns or 100 crowns. You don't want that, right? You don't accept it. You're going to call the bank and you're going to be real upset. Okay? So don't accept from yourself any engineering calculation results that are not at the same level of accuracy that you expect your bank to handle your money and your salary with. Okay? So don't be sloppy. The numbers do matter to somebody. Okay? So anyway, so that's enough preaching about money. And, but you see, the round off thing is more than what you think. Okay, so let's now do a short jump into Excel. Now I'm using a version of Excel. It's 2003. It's because I haven't learned 2010 yet. And yes, I realize 2003 is about 10 years ago, and 2010 is only 2 years ago. Okay, I realize all that. I'm just a slow learner. But I think conceptually, you'll catch most of the points that I'm making, and the difference between 2003. How many use 2003? Still. How many use 2010 or 7? Okay, most of you. Okay. Well, it's my fault not staying up to date with technology that I can't show you all these things in 2010, because if I did that, you'd be hand-holding me. We'd never get anywhere. Okay? And I just want to get across some fundamental, what I call Excel etiquette. Excel etiquette for engineers. Okay? How you should do things and how you should not do things in Excel as an engineer. Okay. So we go in and we're just going to put something in here. Ideal gas law exercise. Okay. It kind of says what we're doing. It's me, Curtis Whitson, because your Excel sheets are not just for you. Your Excel sheets are for your colleagues and the people who remain behind you when you go to another company. Because you may be making Excel sheets that are used and will continue to be used after you get run over by a bus or you change companies. Okay? So they want to know who to blame. Okay? And then we've got, what is it, August 24th, 2012. Something like that. Basic stuff. What it's about, who's doing it, what's the date. Okay. And then I've got the ideal gas law. What I'm going to plot is on the x-axis pressure and on the y-axis volume. Okay? But I'll put it in like this, volume, and we've got units. I guess we can use, how many want me to use SI metric units? Okay, that's the majority. Sorry. Okay, I'll throw in a little of this field stuff. Okay, so we got cubic meters, except that's not very good. Bar absolute and cubic meters. Okay, we're going to do some stuff here. Okay, I generally center. Now, you have a trade-off in spending your time. And although m to the 3 is not clear that it's cubed, I know that 99 out of 100 engineers looking at my sheet will realize cubic meters. Okay? The one who doesn't, my time is too precious, because if I want to go in and do this as an exponent, format, cell, all this stuff, I have too much time. It means that I don't have enough kids yet, enough a wife, or or a life, a party. It's too much. But if you do this, you shouldn't be an engineer. Okay? This is totally, absolutely unacceptable. To put a number without a unit. And if you do it on your exercises when you hand them in, I'll ask the student assistants to hand it back and say it's not approved. Okay? You have to put units. Okay? So that's it. And do I write pressure or do I write P? Okay? That's a decision I have to make. It depends a little bit who it's for. Okay? It's a little bit up to you. I'm not going to dictate to you, oh, you have to write pressure and you have to write P. But in some situations, you'll find that you need to give enough explanation because you know the Excel sheet's going to be used by 3 or 4 other people. Then it's better to be clear, not to be ambiguous. So I got pressure and volume. You know, I center these. And then I'm going to, the equation has temperature, and that's going to be fixed in my case here. I'm going to say, so what's the temperature? I have to give a unit, you see. We need the gas constant. This is SI units, which I should probably write, which is Pascal. It's actually, it depends how you want to do it. You can either use the 8314, which has Pascal, or I can go into that thing here, and I can say, oh, actually we have bar, this one here. I can use that. Bar, cubic meters, Kelvin, and kilogram. That's what I prefer doing. So I'll use, my units are bar. You don't really need absolute. Kelvin, kilogram, and what else? Cubic meter. Okay? And that number was 0.08314. 0.0831443. Okay? 0.0831443. Every number I input that I type in, every number in all of my Excel sheets, the last, I don't know, however long I've been doing, I put it in red. Now, why do I do that? Do I like red? You know, it could be pink or it could be blue or, okay. Why would I do that? It means that I can go back to an Excel sheet I wrote 6 years ago, and I can immediately identify on every sheet, in the file, what are the numbers I change? What are the numbers that I can change? All the other numbers will be calculated. And if you've ever worked with Excel, you'll find that that's one of the biggest problems. I hand you an Excel sheet, it's got hundreds or thousands or tens of thousands of numbers. You don't know which ones are being calculated, which ones are expected to be input. Okay? So every number I input, I just put it in red. Temperature. Pick a temperature. 100 degrees C. That's a good average reservoir temperature around the world. They range from 30 C to 300 C. But on average, not 300 C, but 200 C. From 30 C, shallow in Iraq, Oklahoma, to 200 C, a few places. 200 C is quite high. So I'll give you an average reservoir temperature, 100 C. Got to make it red. Okay. Now I know that I have to use Kelvin in the ideal equation, right? Now I can either in the equation itself add 273.15, or I can do it once, okay? Instead of doing it in a bunch of equations. So what I'm going to do is I'm just going to calculate from this. I'm going to go up here, add the 273.15. Okay? And then it's only done one place. And it's not in red because I don't want to change the Kelvin. It's calculated. Now the pressures of interest in petroleum are 1 atmosphere, which is about 1 bar, to about 1,000 bars. That's the range. More than 1,000 bars, it's probably out there somewhere. I haven't worked on it, and I've worked on most reservoirs around the world. So 1 to 1,000 bars, 3 orders of magnitude. So I'm going to do a range, and I want to plot how the volume in the troll field changes from 1 atmosphere or 1 bar up to higher pressures. Okay? And I'm going to put in here the volume of the troll field. Volume, I'll just write it as G. That's the initial gas in place. So it'll remind me. G is the symbol. And it was 4510 to the 12th. Standard cubic feet. Okay? Okay. Now, because I want to make a plot of pressure from 1 to 1,000 bar, probably running out of time here soon. If I just write 1, 10, 100, 1,000, we'll have 4 points. It's not enough to get the kind of the number of points if I want to maybe do some smoothing or plot a line. So I probably want more than that number of points. But we got 3 orders of magnitude to go over, right? So how to do that? So this is generally how I do it. You can do like 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you do 10, 20, 30, 40, 50. Okay. Okay. So we can do that. Okay. And if you want to get clever, you can just do this. You can grab onto 2 of them and take it out until it gets 9. And then I'll do 10 and 20. And again, you can just grab onto that. We got 100, 200, and then 1,000. Okay, it's enough points. Now, to calculate the volume, you need the pressure, temperature, and number of moles, right? Okay. We don't have the number of moles yet, right? But we do have of course, now I'm mixing units. This is so instead of the 45, we could put in our number from the calculations here, though we have 2 numbers. 127.6. You like it better? You like the average? I'm not sure what to pick. 127.5. Let's take that. 127.5. 10 to the, what was it? 10th? Okay. Now we've got our metric. And now we're going to get kilogram moles by taking what? By taking this, well, we could just go over here and copy it from here, but we'll actually include that calculation in here. We take and divide the gas volume at surface conditions divided by our magic number of 23.6, I don't remember, 23.68. Okay. And that should not be in red. Okay. Now he's going to come in here. He's a big guy. He's a strong guy. He doesn't look so big, but he's much stronger than I am. So he's going to come in and get upset. So we'll stop here, and then we'll continue next Tuesday.